Today we will start next topic, and that one is non-linear partial differential equation of first order. Non-linear partial differential equation of first order. As you know, in last presentation we have already discussed, already defined what is partial differential equation and how can we formulate all these type of partial differential equations, and we have discussed already by eliminating arbitrary constants we can formulate a partial differential equation, or by eliminating arbitrary functions we can also formulate a partial differential equation. Then we define what is solution of a partial differential equation, right? How can we evaluate the solution of all these type of differential equations. Then we have discussed linear partial differential equation and then quasi-linear partial differential equation, and standard or general form of quasi-linear partial differential equation is Lagrange's linear equation. Then we derive Lagrange's auxiliary equations, right, and then we see the method, Lagrange's method to find the solution of these type of problems. Now today we will discuss non-linear partial differential equation of first order, and particular in next lecture we will discuss a general method for evaluating such type of equations, and that method is known as Charpit method. So in next lecture we will discuss Charpit method, but before that general method, let us solve some standard forms like function of pq is equal to 0, function of z pq is equal to 0, function of xp is equal to function of yq, and z is equal to px plus qy plus f pq. अगर इस टाइप की फॉर्मेशन हमारे पास अगर एग्जिस्ट करती है, ठीक है, ये कुछ स्टैंडर्ड फॉर्मेशंस हैं, राइट, देन हाउ कैन वी इवेलुएट द सॉल्यूशन ऑफ दिस टाइप ऑफ नॉन लीनियर पार्शियल डिफरेंशियल इक्वेशन. So a partial differential equation which involves first order partial derivatives p and q of degree higher than 1, degree higher than 1. Clear? A partial differential equation which involves first order partial derivatives p and q of power or degree higher than 1 and or product of terms p and q is called a non-linear partial differential equation. So some special type of all these type of equations are now going to present. Okay. So first one is equations of the form function of pq is equal to 0, means equations involving only p and q and no x, no y, no z. Clear? So those equations which involves only p and q, then how can we solve these type of problems? And second part we will discuss those non-linear partial differential equations which are easily reducible to this standard form. Okay, then how can we solve those type of problems? Now second one is this equation of the form z is equal to px plus qy plus function of pq. Okay. Third one is equation of the form function of z pq is equal to 0. Okay. So when we discuss all these type of forms, then we will also discuss few examples which can easily reducible to this particular form or this particular form. Okay. And fourth form is equations of the form function of xp is equal to function of yp. तो x और p के जो रिजल्ट्स होंगे, एक्सप्रेशन होंगे, वो एक तरफ रखने हैं, y और q के एक्सप्रेशन आपने दूसरी तरफ रखनी है, राइट. देन वी कैन सॉल्व दीज टाइप ऑफ प्रॉब्लम्स. ओके. So first one is equations of the form function of pq is equal to 0. How can we solve these type of problems? Now in this case, complete solution is z is equal to ax plus by plus c. So in this case, when we have this type of partial differential equation, means function of pq is equal to 0, okay, then in that case complete solution is z is equal to ax plus by plus c, where a b are connected by the relation fab is equal to 0. fab is equal to 0. We have given function of fpq is equal to 0. Clear? So when fpq is equal to 0, then solution is this, where this condition holds good. Okay, where p is curly z over curly x, which is equal to a in this case, and q is equal to curly z over curly y. In this case, result B. Okay. Now from this 2 we can find B in terms of A. So from this relation we can find the value of B, okay, and that one is a function of A. Clear? We can write this equation like this way. Okay. So B is function of A. Clear? Then putting this value okay, here, then you will get this. You will get this, and that one is the complete solution of this partial non-linear partial differential equation. Okay. So solve this problem. Solve the following partial differential equation: under root p plus under root q is equal to 1, and second is p q is equal to p plus q. Now see, the given differential equation is this. This one is the given differential equation. Okay. So this one is a non-linear partial differential equation of the form function of p q is equal to 0. So left side is a function of p and q. So function of p q is equal to 0. Clear? So you can write 1 here. So under root p plus under root q minus 1 is equal to 0. So left side is a function of p q and right side is 0. Okay. Then complete solution, as we know, this z is equal to ax plus by plus c, where f a b is equal to 0. That condition is satisfied. So here f a b means f p q is under root p plus under root q is equal to 1. So this means under root a plus under root b is equal to 1, and from this result calculate the value of b. So b is 1 minus under root a square. Substitute this value of b here. Okay. Substitute this value b here. You will get the required solution of non-linear partial differential equation, which is of this form function of p q is equal to 0. So this one is the solution. This one is the solution. So in this way you can find the solution of these type of non-linear partial differential equations, where specifically we have given this type of differential equation, this type of non-linear partial differential equation. Okay. So first write the differential equation. Okay. Compare with this differential equation. This differential equation is of this standard form. Then complete solution, as we know, is z is equal to ax plus by plus c. Okay. Where this f a b is equal to 0. So under root a plus under root b is equal to 1, means b is equal to 1 minus under root a square. So substitute this value here, you will get this one is the solution. Similarly, calculate second part. Now this one is the given differential equation, which is non-linear partial differential equation, right? No, complete solution is z is equal to ax plus by plus c. Okay. Now this means a b is equal to a plus b. Okay. F a b is equal to 0. Satisfy that particular condition. Okay. F a b is equal to 0 means replace p by a and q by b here. So you will get a b is equal to a plus b, and from that relation calculate the value of b. Calculate the value of b. Okay. Now substitute the value of b here. Substitute the value of b here, then you will get this one is the solution. You will get this one is the solution. Okay. So in this way you should try to solve few more problems related to this topic. Okay. So when equation of the form function of p q is equal to 0. Now let us solve one problem which can easily reducible to this standard form. Okay. Now see this example. Solve the following partial differential equation: y minus x into q y minus px is equal to p minus q square. Clear? Now this given the differential equation is this. Okay. Now this equation is not of the form function of p q is equal to 0. आप इस equation को इस form में नहीं लिख पाएंगे अभी. Okay. But by proper substitution you can convert, you can reduce this differential equation to this specific form. Okay. So what this can be reduced this as follow. So in this problem substitute, let us suppose x plus y is equal to capital X and xy is equal to capital Y. So when you substitute all these supposition, then what happened? What is the value of p? P is curly z over curly x, and that curly z over curly x can be written as curly z over curly x into curly x over curly x plus curly z over curly y over curly x, and that one is curly z over curly x plus y curly z over curly y. Okay. So calculate this one. Okay. So calculate the value of this result. Okay. That one is y. Curly y over curly x is y. So from this you can calculate the value. Similarly, calculate the value of q. Q is obviously curly z over curly y, and that can be written as curly z over curly x over curly y, plus curly z over curly y over curly y. Okay, and then calculate the result. Okay, so you will get these two expressions p and q. Now calculate qy minus px. So we need qy minus px. So first calculate qy minus px. So qy minus px is this result. Now next we need p minus q. So p minus q is y minus x outside the bracket curly z over curly y. So when you calculate the value of p and q, so calculate this expression and this expression. Now then substitute all these expressions here. Okay, so then you will get curly z over curly x is equal to curly z over curly y square. So you will get this type of expression. Okay, and suppose this one is capital P and this one is capital Q, then it becomes P is equal to Q square. P is equal to Q square, and that can also be written as function of PQ is equal to 0. Function of PQ is equal to 0. Okay. Now when this differential equation reduces to this standard form, function of PQ is equal to 0, then you can solve this type of problem. Okay. Then complete solution is obviously z is equal to a capital X plus b capital Y plus c. Okay. And from 1 complete solution is z is equal to ax plus under root a y plus c. So from this relation, okay, so calculate the value of b, right? From that result calculate the value of b. So a is equal to b square. So calculate b is under root a. So substitute value under root a here. Okay, b as it is plus c. Clear? So simply solve and you will get this one is the solution. Okay. So in this way, by proper substitution, okay, you can reduce few complicated problems, okay, of non-linear partial differential equation to this standard form, which can be easily solvable. Okay. Now second part is equation of the form z is equal to px plus qy plus function of pq. Clear? Z is equal to px plus qy plus function of pq. Then what is the complete solution? Now remember, in this case the complete solution is z is equal to ax plus by plus function of ab. Means, and that solution can be obtained by writing a for p and b for q. That one is the solution. Clear? Now solve this problem and first compare this problem with the standard form. ये प्रॉब्लम किस स्टैंडर्ड फॉर्म के साथ मैच कर रही है. सो दिस स्टैंडर्ड दिस डिफरेंशियल इक्वेशन, इफ वी कंपेयर विद दिस differential equation, then you can solve by using this result. Okay. So given partial differential equation is this, and this one is a non-linear partial differential equation of first order, where z is equal to px plus qy plus function of pq. Okay. Then its complete solution is z is equal to ax plus by plus under root 1 plus a square plus b square. That one is the solution of this partial differential equation. Okay. तो ये प्रॉब्लम बड़ी सिंपल है, क्योंकि ये जो स्टैंडर्ड फॉर्म है उसके साथ 100% मैच कर रही है, कुछ भी एडजस्ट करने की जरूरत नहीं है. राइट. सो दिस प्रॉब्लम इज वेरी सिंपल, बट यू जस्ट रिमेंबर, if we have this type of partial differential equation, then what is the solution? And in this case solution is z is equal to ax plus by plus function of ab. Okay. Now equations reducible to the form this z is equal to px plus qy plus function of pq. Okay. So solve this partial differential equation. 4xyz is equal to pq plus 2px square y plus 2qxy square. So solve this differential equation. तो पहली नज़र में आपको लगेगा नहीं, ठीक है, कि ये इक्वेशन तो इसके साथ मैच कर भी नहीं रही है. क्लियर. तो इस टाइप की प्रॉब्लम को आप कैसे सॉल्व करोगे. ओके. सो दिस इज नॉट ऑफ द फॉर्म, this differential equation is not of the form z is equal to px plus qy plus function of pq, but this can be reduced to this form by substituting x square is equal to x capital X, y square is equal to capital Y. x square is equal to capital X, y square is equal to capital Y. ठीक है. तो थोड़ा सा आप हिंट यहाँ से ले सकते हो कि इस टाइप की इन्वॉल्वमेंट है. So put this result is x and this result is y. Then calculate the value of p. So p is equal to 2x curly z over curly x and q is equal to 2y curly z over curly y. Clear? Now substitute all these values p and q in the given differential equation. So when you substitute 4xyz as it is, 4xy curly z over curly x curly z over curly y plus 4x cube y curly z over curly x plus 4xy cube curly z over curly y. Just substitute all these expressions, the value of p and q in the given differential equation. In this given differential equation, you will get this result. Okay. Now simplify. Simplify this 4, this 4, this 4, this 4 and this 4 cancel, right? And this xy, this xy cancel, so x2 and y cancel, x and y2, clear? Now, we get this type of result, okay? Now, simplify, more simplification, we get this result, okay? And if you compare, okay, if we substitute curly z over curly x is capital P and curly z over curly y is capital Q, then it becomes this form. Z is equal to Px plus Qy, Px plus Qy is equal to Pq, means function of Pq. Then what is the solution? Solution can be written like this way. Z is equal to Px plus Qy plus function of Pq, then solution becomes Z is equal to Ax plus By plus Ab. Plus AB. Now substitute the value of x and y. So capital X is x square, capital Y is y square. So this one is the solution of this non-linear partial differential equation, which is of this form after reduction, okay, by substituting x square is equal to capital X, y square is equal to capital Y. So in this way you can solve these type of problems, ठीक है? तो अब आप देखिए दो मेथड कर ली है आपने, ठीक है? फंक्शन ऑफ पी क्यू इज इक्वल टू 0, उसका सोल्यूशन कैसे लिखा जाएगा, ओके? वो आप देख लो कैसे उसको लिखना है, सोल्यूशन कैसे लिखना है, और उस सोल्यूशन को डायरेक्टली नहीं लिखोगे, आप एक कंडीशन को भी साथ में रखोगे, फंक्शन ऑफ ए बी इज इक्वल टू 0, just by replacing p by a and q by b, okay? And in this problem, if we have this type of equation, then solution becomes just by replacing p by a and q by b, okay? We get the solution. Now third case is interesting. Equation of the form function of z p q is equal to 0, that is equation not containing x and y. तो ऐसी नॉन लीनियर पार्शियल डिफरेंशियल इक्वेशन जिसमें y और z नहीं है, x और y नहीं है, क्लियर? z है, p है, q है. Now how can we solve these type of problems, okay? So let us assume that z is equal to phi x plus ay, or x plus ay is u, so phi u, function of u. So where u is x plus ay as a trial solution. So let us consider this one is a trial solution of the given equation. Then from this calculate the value of p. P is x dash, phi dash x plus ay. This can be written as phi dash u and that can be written as curly z over curly u, okay? And q is phi dash x plus a by a, so that can be written as a phi dash u, which is equal to a curly z over curly u, clear? Now substitute all these values, right? Then all these values of p and q, p is this, okay, and q is this. Then you will get this function of z p q is equal to 0, means function of z, p is curly z over curly u and a curly z over curly u. So this one is curly, okay, curly, not d, curly, okay, curly z over curly u and curly z over curly u. Now, but here one important point is, okay, here if you see z is a function of only one variable u, right? So when we have z is a function of only one variable, independent variable, then we cannot write curly z over curly u, okay, curly z over, so this one is okay, curly dz over du, okay, and dz over du, okay, this one is correct, right? Because z is a function of only one independent variable. So which is the ordinary differential equation of first order, okay, integrating it we get the complete solution, clear? So जब आप इसको substitute कर लोगे तो that one is the ordinary differential equation of first order, okay, और इस type की equation को आप solve easily कर सकते हो by using the various methods which we have already discussed in ordinary differential type of equations. So what is the method? Assume u is equal to x plus ay, so that p is equal to curly z over curly u, q is equal to a curly z over curly u. Substitute these values of p and q in the given equation. Solve the resulting ordinary differential equations in z and u and replace finally u by x plus ay. We get the result, okay, we get the result. So that one is the method for evaluating the solution. Okay. So let us solve this problem. Solve the following partial differential equation: z square into p square plus q square plus 1 is equal to a square. Let us consider this type of example. Okay. So solve this following partial differential equation, which is non-linear partial differential equation, right? So, and this partial differential equation is of this form. So there is no x and y. So that means function of z p q is equal to 0, right? Then how can we write the solution? Now let u is equal to x plus by. Note the use of b instead of a, since a is given in the constant. So a is already given, so we apply here, we use here b in place of a. So u is equal to x plus by. Now calculate p. P is equal to curly z over curly u. Curly z over curly u. And what is q? Q is b curly z over curly u. Clear? So p is curly z over curly u and q is b times curly z over curly u. So substitute all these values of p and q here, right? So when you substitute, then what happened? This z square, p square means dz over du square plus b square dz over du square plus 1 is equal to a square. Okay? And simplify, you will get this result. And integrating both side, clear? Integrating both side. So when you integrate both side, we get plus minus 1 plus b square under root a square minus z square under root is equal to u plus c. So u plus c. So ultimately we obtain this solution, relation between x, y, z. Okay? So we obtain this type of solution. तो इस टाइप की प्रॉब्लम को भी आपने देखना है कि इस टाइप की प्रॉब्लम्स को आप कैसे सॉल्व कर पाओगे. ओके. Now next one is equation of the form function of xp is equal to function of yq. क्लियर? तो अगर आपको ऐसा लगता है ये नॉन लीनियर डिफरेंशियल इक्वेशन, पार्शियल डिफरेंशियल इक्वेशन इस टाइप से है कि आप x एंड p को वन साइड कर पा रहे हो और y एंड q को अनदर साइड कर पा रहे हो, तो ये प्रॉब्लम फिर इजीली सॉल्वेबल है, राइट? सो इक्वेशन इन विच z इज एब्सेंट एंड द टर्म्स इन्वॉल्विंग x एंड p कैन बी सेपरेटेड फ्रॉम दोज इन्वॉल्विंग y एंड q. So as a trial solution, let us put each side equal to an arbitrary constant a. So as a trial solution, let us put each side equal to an arbitrary constant a. Clear? So this means that function of xp is equal to function of yq is equal to a. So each side equal to some arbitrary constant a. Solving the equations for p and q. So p is function of x, q is function of y. So when you solve this part, f xp is equal to a, f yq is equal to a. So then you will get p is equal to function of x, q is equal to function of x. And what is dz? dz is curly z over curly x dx plus curly z over curly y dy, and that can be written as p dx plus q dy. So dz is equal to f1x dx plus f2y dy. Integrating on both sides, we get z is equal to integral f1x dx plus integral f2y dy plus b, and that one is the complete solution after solving these integrals. Which one is the required complete solution? So this one is the methodology for evaluating the solution for this particular special case, when equation of the form function of xp one side and that one is equal to function of yq in another side. So solve the following partial differential equation: yp is equal to 2yx plus log q. Yp is equal to 2yx plus log q. Solve this type of differential equation. Now see, the given partial differential equation is this. This one is the given partial differential equation, and this equation can be written as this. So rewrite or simplify this differential equation like this way: p is equal to p minus 2x is equal to 1 over y log q. Okay. Now here x and p one side and y and q another side. So function of xp this is equal to function of yq this. Clear? Now let p minus 2x, this p minus 2x is equal to 1 by 2 log q, which is equal to a, which is equal to a. Then what is p? P is 2x plus a, and log q is, or q is equal to e raised power ay. Clear? So now dz is equal to p dx plus q dy. So p is this, q is this. 2x plus a dx plus q means e raised power ay dy. Now integrating both side, we get z is equal to x square plus ax plus 1 by a e raised power ay plus b, and that one is the complete solution for this problem. Okay. So method is simple. Okay. We have given this type of differential equation, right? And after rewriting, we can write this type of differential equation like this way. Clear? Now equal, and when we write function of x p is equal to function of y q, let us suppose that that one is equal to a. Okay. So this result is equal to a, this result is equal to a. So from this calculate the value of p, from this calculate the value of q. So p is this and q is this. Okay. And we know dz is equal to p dx plus q dy. Just substitute the value of p and q, and then integrating both side, you will get the required result. तो इस टाइप की कुछ और प्रैक्टिस करिए 5-10 प्रॉब्लम्स की, ठीक है? तो जब आप प्रैक्टिस करोगे तो ये सारी कंसेप्ट जो है वो बिल्कुल क्लियर हो जाएंगे. ओके. वन मोर प्रॉब्लम, p स्क्वायर माइनस q स्क्वायर इज इक्वल टू x माइनस y. So p square minus x is equal to q square minus y. So this differential equation is non-linear partial differential equation of this form. Okay. So p square minus x, so function of x and p one side, function of y and q another side. Okay. And let us suppose that this one is equal to a. Okay. This one is equal to a. Clear? So when this result is equal to a, then find the value of p. When this result is equal to a, then find the value of q. Clear? And substitute dz is equal to p dx, substitute here dz is equal to p dx plus q dy. So p is x plus a under root dx plus q is y plus a under root dy, and integrating. So when you integrate, you will get this one is the solution. तो ये कुछ नहीं है, ये तो जस्ट एक इंटीग्रल है, ये आपको आप आसानी से इसको कर पाओगे, राइट? सो दैट वन इज द कंप्लीट सॉल्यूशन ऑफ दिस नॉन लीनियर पार्शियल डिफरेंशियल इक्वेशन. तो इस तरह से आपने ये जो स्टैंडर्ड फॉर्मेशंस हैं, ठीक है, स्टैंडर्ड फॉर्म जो है नॉन लीनियर पार्शियल डिफरेंशियल इक्वेशंस की, अगर कोई भी डिफरेंशियल इक्वेशन इन चार में से किसी पर्टिकुलर फॉर्म में अगर बनती है तो उसका सॉल्यूशन इजीली पॉसिबल है. क्लियर? बाय यूजिंग दीज वेरियस techniques. Okay. So next time we will discuss the general method for evaluating the solution of non-linear partial differential equation of first order. Clear? And that one is very important method, and that one is known as Char-Pit method. Clear? So next time we will discuss Char-Pit method. Thank you very much.